today, in my last class, I discussed about different how the switching converters are important over the linear power converter. Okay, and discuss about different power loss calculations for our linear power converter instead of switch mode power converter. So all the calculations I've done. Finally, I concluded in my last class about the design of filter and the selection of the cutoff frequency. Okay, so selection of cutoff frequency and the relation between the switching frequency and the cutoff frequency. Okay, so after that, I take some example like a buck converter. Okay, then initially I would not select the filter, means LC filter over there. Okay, so after that I will select some LC filter, and finally we will calculate the power calculation. So where it was concluded that power loss is very small for the switching converter, because you can see over there input power is near about 500 watt, output power also near about 500 watt. So you can conclude that power loss in the switching converter is very less. Okay, then choose the filter cutoff frequency f0. Okay, much smaller than the switching frequency fs. So normally it is taken by 1/5 or 1/4. Also we are taking sometimes it is 1/10. Okay, so it's the configuration is known as a buck converter. That was discussed in our earlier class. Okay, so it was earlier ideally lossless LC filter you have considered. Okay, so if it is lossy in nature, then another expression will be coming. Okay, so then next section is the additional control system for the regulation of the output voltage. Okay, so what is the regulation? Regulation means I think in details I have not discussed. Okay, but someday I will discuss about the regulations. Okay, what are the normal type of regulations? Okay, so you know that I have already discussed that normally three types of regulations are there. Okay, so one is called that line regulation. Okay, so why first we need to know that why the regulation is important. Okay, so because of that the output voltage of the power supply may be affected by what are the most important features. Number one is the variations of the input voltage. Okay, variations in the load current. Okay, and finally the variation in the temperature. Okay, all of you please note down. Okay, so because that is actually I have discussed you through my voice. Okay, then what happened, you have to prepare the class note. Okay, and it will be sent back to me. Okay, so that's why it is important. So in your class note you should write each and every points that I have been discussed over here. Okay, so that I have told you that variations of your input voltage, variations in your load current, and the variations in your temperature. Okay, so normally what happened in a regulated power supply has a feedback circuit. Okay, to compensate of such changes and keep the output voltage within the specific limits. Okay, that's the basic that's why the basic concept of regulation has come. The compensation provided may be specified separately as load regulations, okay, line regulations and temperature regulations. Okay, so you can understand that three variations, tentative variations are there. So instead of the three tentative variations, what are the most important regulations? Okay, your load regulation, line regulation and temperature regulation. So what is line regulations? Okay, so line regulation is a measure of the effect to change in the input voltage on the output voltage. Okay, so you have to understand that in your line regulations means in your input side is there any changes are there. So what are the exact changes in your output, that you have to calculate. Okay, so if your system is stable, okay, and it will be work properly, then what happen, then there will be no such changes of your output voltage, any kinds of changes in your, that means instead of changes in your input voltage. Okay, there should not be any changes. Okay, if your system is working fully stable condition. Okay, so there is a variety of method used to specify line regulations. However, a common definitions. Okay, so now you can understand the regulations expressions. Okay, so what is your line regulation expression that is written? That line regulations equal to delta V0 by delta V0 by V0 into 1 by delta V in into 100% per input voltage. Okay, that means what is that expression? Delta V0 by V0 into 1 by delta V in means the into 100% per input voltage. Okay, delta V0 means the percent, that means the little or very small changing of your output voltage. So delta V0 means changes in your output voltage. Delta V in means what? Changes in your input voltage. So delta V0 by V0 means the ratio, the changes of the ratio in between the changes in your output voltage to your only output voltage, means reference output voltage, into with the ratio of delta input voltage, means the how much voltage is, how much voltage variation in your input side. Okay, so it's an expression is coming instead of, it's a ratio. Okay, because that's why it is you can say like this, it is the regulations, it will be coming per input voltage, because delta V0 by V0 means volt maybe cancel each other, then 1 by delta V in, so only voltage, so 1 by V is coming, so unit of regulation is coming, that 100% means 1 by instead of per voltage. Okay, that's why it is coming, that is per voltage. So from that figure you can easily understand that which one is your source, VG, it's a DC source. Okay, so and if any kinds of false or any kinds of additional voltage is coming in your input side, means input of that converter. Okay, input of that converter, then what happened, then it will try to what, it will try to increase the output voltage. So what is your output, that is V0. Okay, so here it is written V, so it is try to increase. Okay, but if your control is work properly, that means your control system for the regulation. Now, if your control system is work properly, then what happen? It will regulate the, it will changing the pulse width modulations. Okay, so if the pulse width modulation has changed, so PWM width will be changing with the changing of the reference voltage. So from where it is coming, that VC control voltage it is coming. So by the changing of your control voltage, so pulse width of the converter has changed. If the pulse width of the converter has changed, then it will directly affect to the driver's circuit. Okay, so that's why it is written transistor gate driver. Okay, so and that variations of the width will be appear directly to the MOSFET switch. Okay, if it is appear like that directly to the MOSFET switch, definitely the output voltage will be regulated. Okay, and it will be try to be fixed within the tolerable limits. Okay, so definitely the percentage of regulation, how much is there, that you have to be calculated. Okay, so suddenly you have designed on power supply. Okay, because end of the day you are the power electronics engineer, so you have to design the power supply for the specific application. Okay, so you know the specifications. Okay, means input current, input voltage, output current, output voltage. If you all the data are available, so you can easily identify the power of the input, power of the output. Okay, then any kinds of changes is there, so how much power changes will be there and how it will be calculated. So which switch you have to be using, so that also be decided by your side as per the switching frequency of the device. So how much operating switching frequency is there, that you have to calculate. Okay, so if you know that value, so as per the switching frequency you can select the power electronics devices. Okay, there is no problem. So now with the changes of the input side, so how much changes of your output side and how it will be fixed up. Okay, so directly it is called the regulations of that output voltage. So you can understand the input regulations. Okay, so now you can note down that it should be noted that this definition implies a linear relationship between the input and the output. Okay, that means that means a change in input voltage will produce a proportional change in output voltage. Means how much, that's why it is written na delta V in. Okay, so how much proportional changes is there input side and how much proportional changes is reflected to your output side. That is most important, which often does not exist. Okay, for this reason many manufacturers specify an input voltage range for which the power supply output will stay within the specific limits. Okay, so that I have already told you, the rating of the power supply is most important, and how much you can allow for it. Okay, that means the tolerable range, that also very important issue. Okay, so I think all of you are able to understand the line regulations. Then you can go for the load regulations. Okay, so the same thing also be happened in your, there will be no changes in your input side, input voltage will be same, but some of the additional voltage is appeared to your output side. Maybe some additional resistance is there, due to some additional resistance, so some of the current is passing through that resistance, that may cause for additional loss, additional voltage drop, because current is changed. If you connect in series with that load another resistance, the current may be same but voltage may be different. Okay, because because the exactly that drop will be there for this load. Okay, then additional drop will be there for that additional load. Okay, that drop directly adding over there, but you have to maintain the output voltage V fixed. So again the concept of regulation will be coming. Okay, so again it will modulate, the pulses of the switches and making it fixed. Okay, so without any changing of that, without changing of your output voltage. So you can say, like that, the load regulation is the percentage change in the steady state output voltage. Okay, when the load current is increased from 0 to fully rated current. Okay, so you are changing the load current from its 0 to maximum, how much range it can be gone. Okay, or more commonly from 50% to 100%. Means if you can say like that, 50% means if it is in your 5 ampere, your load current you have designed that like a 5 ampere. So 100% means another 5 ampere, means you are checking your load regulation in the range of 10 ampere, and 50% means it will be reduced as a 2.5 ampere. Okay, so if the current is changing, okay, if your load current is changing, then what happened? Power must be fixed anyhow. Anyhow your power must be fixed. It means if your load current is changing, directly load voltage will try to be increased. Okay, but you have to initially current is decreased, means current is dipping. Your rated current is 5 ampere, then directly it is rated dipping to 2.5 ampere. Then what happened? So initially voltage will be dipping down of the current, because power is constant. So what happened? Directly voltage, there you can see that there is voltage transient. Okay, overshoot of the output voltage, but you have to settle down that voltage to the steady state value. That's why it is written the steady state output voltage. Okay, percentage of change in the steady state output voltage. It should not be taken in the transient condition. The previous line regulations also not taken in the transient condition, due to the additional line voltage and the load voltage that may cause for the transient effect. Okay, then it is important that how much response time. So how much response time means it is your rise time. So how fast your system is behaving. Okay, means is responding, that is a response time. Response time is equivalent to rise time. Okay, so that's decided as per decided the transient nature or transient response of your converter. Okay, of your power supply. So this does not take into the account of the transient effects which may occur. Okay, so you can understand. So transient effect is not there, but due to changes in your load side or the line, that means load voltage or load current or the line voltage, so the transient response may occur, but it should be steady. It should be fixed up at the steady state condition as early as possible. So who will decide that rise time? Definitely your controller. So you can see like the GCS. So it is a controller transfer function. So controller will take care about it. So how fast it will be settled down. Okay. So what is your load regulation expression? So it is that load regulations equals to VNL minus VFL whole divided by V norm. Okay, V in suffix NOM into 100%. So what is your VNL? It is your output voltage on no load. Okay, VFL means output voltage on full load, and V norm means nominal output voltage. Okay, so no load voltage minus full load voltage whole divided by nominal output voltage means it is your reference output voltage, that is your reference input. Okay, reference output voltage. So it is Vref. So V no load minus V full load whole divided by V reference or V nominal. Okay, the load regulation is often quoted from 50% to 100% loading rather than 0% to 100% loading. So why it is not 0% to 100% loading? Because 0% means it is 0 means 0% loading means there is no such changes of that load current. So the regulation will not be occurred, but for the significant operations means how do I understand that how much significant operation is there? So normally you have checking it is 50%. Okay, minimum is 50%, maximum is 100%. Okay. So I think all of you are able to understand the concept of line regulation, load regulation. Now we can go for that temperature regulations. The same thing also happened for the temperature. Due to temperature, there should not be changes. Anything there should not be changes in your output voltage. That should be the basic concept of the temperature regulation. So how do you define it? So there are several different methods of that quantifying the effect of temperature on the output voltage. Okay. But many power supply manufacturers specify the temperature coefficient, that is TC. Okay, that is TC, whereas TC means temperature coefficient. It is V0 max minus V0 mean whole divided by V0 norm. Okay, into 1 by T max minus T mean. T is in your capital. Okay, into 100% per degree centigrade. So what is your V0 max? So output voltage is maximum rated temperature, means because you know that it's a solid state device, so there is a definitely the resistance is very less. Okay, so resistance is very less. Definitely the current will be very high. I square R loss will be very high. That's why there is some with definitely the due to the Joule's law, I square R T, the heating effect will be there. Due to the one is cause, another one is effect. So if it's heat is cause, so temperature will be the effect. Okay, so there is generation of heat means definitely there is some changes of the temperature. If the changes of the temperature has been occurred, then the doping, you know that the direct effect of the semiconductor devices, the changes of the temperature. So you can understand the effect. Okay, so directly that resistance path will be changes. Okay, so that's the basic reason. Okay, the notations of the, that means specifications of the temperature in the power supply. So that's why you can see in your computer SMPS. I think all of you have laptop, maybe desktop. Okay, in our time, that means when I studied in my BTech and MTech, that time desktop was very popular, na? Very that means in the year of approximately 2010 2012. Okay, so that time desktop is much more available in our market, so we are normally assembling. Okay, I think all of you are able to, I don't know that you are able to do the assembling of the computer or not, but we are when I was in BTech student, so we are also doing that assembling of our computer. Means initially we just observe that how the other person is assembling, then as per that you can understand by the personal interest of that fellow they can do it. Okay, so then we are doing that assembling. Okay, so what happened in my desktop, I just observed that my SMPS was burned out due to lightning. Okay, so I have changed it. Okay, so how do you change? Means I didn't design it, but I have changed it. I have procuring from there. So one fan all the time you can see. Okay, so one fan is there. The two fans normally observed in that desktop, that means CPU. So one fan in your SMPS, another fan is in the processor unit. Okay, so what happened in the processor, in my first class I told you that huge current within a minimum voltage means 1 volt, but current is 130 ampere. That means load current is too high. Okay, so that may cause huge power loss. Okay, so that may not like directly power loss, that may cause the huge heating effect. So mitigating that heating effect, so you have to install some of the fan. Okay, so that will be revolving and it will making the cooling down. That means force dot in the term of power system, that is called the force dot. Okay, so natural dot, force dot. Okay, so it's a concept of that force dot. So same thing also happen because there is some heat sink and the fan is installed beside of that heat sink and you are blowing the air to the heat sink to dissipating that dissipating means the temperature generated heat, and that may cause for the changing of the temperature. Okay, that you can do it. Okay. So V0 max means in your output voltage at maximum rated temperature. Okay, so V0 means nominal voltage. Sorry, V0 means output voltage at minimum rated temperature. Okay, so I think you can able to understand. Then V0 norm means nominal output voltage, means your reference voltage. T max means maximum rated temperature, T min means minimum rated temperature. Okay, so that all are the notations for the TC. Okay, it means TC means your temperature coefficient. Okay, so the expression of TC is V0 max minus V0 min whole divided by V0, or sorry, I have wrong, so it is not V0, it's a VO, output max. Okay, VO max minus VO min whole divided by VO min, VO nominal. Okay, into 1 by T capital T suffix max minus capital T suffix min whole multiplied with the 100%. The unit will be per degree centigrade. So you can understand for the line regulation, the degree is coming per degree input, sorry, per input voltage, means again the unit is 1 by V. But in case of load regulation, it is unitless. Okay, but again in case of temperature regulation, again it having some unit, that is per degree centigrade. Okay, so many power supply manufacturers specify only an overall percentage of regulation together with the limit of input voltage, output current and the temperature. So what is the regulations right now? So V max minus V min whole divided by V nominal into 100%. Okay, so I think all of you are able to understand. Hello?
We are not able to see the equations in the slide, sir.
Slide is not visible from your side.
That addition of control system for regulation of output voltage, that slide is only visible, sir.
My slide is changing. Is it changing?
No, sir.
It's not changing. Just wait.
Yes, sir. Now it is changing.
Is my slide is visible? Is it visible from your side?
Yes, sir.
Yes, sir.
Okay, now
yes,
it is
sir.
full screen. Is it full screen?
No, sir.
It is not full screen.
No, sir.
Is it visible right now?
Yes, sir.
Okay.
Yes.
Okay. So I just conclude this slide for it. So you can understand the concept of that line regulation. So that line regulations, then your load regulations, okay, and your temperature regulation. So from this figure you can see that one switching converter is there. So one MOSFET switch is there. So as a switching converter, so driver is there. So it's your driver. What is delta? Delta is your PWM, that is coming from here, delta T. Okay, so it is dt, then up to dt it having high voltage, then up, 0 up to ts. Okay, so like that. Okay, and what is your sensor gain? So why the sensor is there? Because isolation. I have already told in my previous class that the isolation is required, because power circuit means it's the range of the power circuit more than 15 volt, but in your control circuit normally we are designed within that 15 volt. Okay, so you have to scale down that load voltage. Okay, who is responsible for the scale down? So normally we are using different sensor, means transducer normally we are using, means LEM transducer, LV25P maybe there. So voltage transducer are there if you are fetching the current, so we will use some current transducer, LP55P I think so. Okay, so that is your current transducer for the LEMA. Okay, so Hall effect sensor. So here you are using some sensor circuit. Sensor means the transducer. Okay, that will sense your output voltage. Okay, and it will stepping down with and making some gain. So HV means H is your gain factor. Okay, so H is coming from your sensor gain. Okay, so H, then V is the multiplied with your, that is V is similar to your output voltage. Okay, so now you are comparing that HV with your V reference. Finally, we will get some error signal, that is VE. So error signal is there. Okay, so due to error signal, now it's a differential amplifier. So it's your differential amplifier. Okay, so here you can observe that it's your differential amplifier. Okay, so that summer block is there. So summer block is nothing but your differential amplifier. So reference is coming to the positive terminal, and output, that is sense. Okay, nominal, sorry, it is your V ref or V norm, that is same nominal voltage, and that minus terminal, it is coming that negative signal. So it is actual output is coming from here. So it is reference output, it is actual output. Then error will be there. Then one compensator, or you can say like that controller circuit is there for minimizing that error, means compensating the error. Finally you will get some VC, means control voltage. So now you can compare. Okay, so by using PWM modulator, means compare with some triangular waveform, that signal, switching signal of that triangular, means switching frequency of this triangular waveform, and that repeating sequence. Okay, and the switching wave both should be the same. Okay, so now you will get some PWM that will pass through the driver circuit to drive the MOSFET. So any kinds of changes in their power input side or the load side. Okay, so entire system will be regulated as per your rated value, and you will maintain the voltage. Okay, that V voltage will be sent. Okay, that will be maintained by the regulations. Okay, I think all of you are able to understand the regulations of the output voltage and the effect of the control system. Okay. Now the single phase inverter. Okay, so switching DC converters, so definitely the switches used as a inverter circuit also. Okay, so here you can see that what is the configuration of the inverter. Definitely input should be the DC and output should be the AC. Okay, so the thing is conceptually both the way same, because you are getting that instantaneous output plus minus directly you are getting. Okay, so you can see two sections are like that. So it is like that too. So it's an example of H bridge inverter. Okay, so what, and it is a modulating signal. So how to get it? So switches are there. So four switches, 1, 2, then 2, 1, means at the angular. Okay, so diagonally they will operate. So one, when the switch 1 is on, then in that case switch 1 also be connected. So it will be like that, the power flow of the current is Vg from switch 1, then there will be inductive capacitive part, so load will be there, then it will return back from here, then it will be coming back to here. When switch is directly connected over here, switch 2 and switch 2, so again the power will be there. So the from current will be passing from here, then to, then it will be, now switch will be in the second position, so current will be in that direction. Okay, then it will be coming back from 2 to again negative terminal of Vg. So you can conclude that both of the cases the direction of current has changed by this configuration. So alternating nature of current we will observe. Okay, as well as if the alternating nature of current is there, definitely alternating nature of that voltage also be found. Okay, so the nature of that output will be in alternating nature, so it should be the AC voltage. So here you can see the modulating signal. So two signals are there in case of inverter. So what is called the modulate switch duty cycle to obtain by the sinusoidal low frequency component. So two signal will be there. One is called the modulating signal, another is called your carrier signal. So normally the carrier signal, the frequency of the carrier signal is high compared to your modulating signal. So normal our line inverter, we are using that modulating signal, maybe modulating sinusoidal modulating signal for the 50 Hz. Okay, or 20 millisecond. In case of time period, it will be 20 millisecond. But carrier frequency, we are normally making it 5K, means 5000 Hz. Okay, so how much variation is there? Modulating signal is 50 Hz, but your carrier frequency is 5000 Hz. So it is multiplied with what? Multiplied with 100 times. Okay, of your modulating signal. The frequency of the carrier frequency is 100 times multiplied with your modulating signal. Okay, so I think you can understand. So you can see it's just, that's why it is written like the low frequency component, sinusoidal low frequency component. So the time period of that sinusoidal will be near about 20 milliseconds. But the carrier frequency, it will be like that, that triangular wave. Okay, so it will be like that. Now compare both of them. So you will get that on off switch means PWM will be there. But if it is comparing with some variable means it is comparing with the sinusoidal wave. So width of the PWM is different. Okay, so in your previous case you can see the width of the PWM is same. Okay, width of the PWM is same. So it's a SPWM. Okay, sinusoidal PWM. That's why that width are different. Okay, so all the cases you can see that width is different. Okay, so width is different means on time will be different. Okay, so I think you are able to understand for the operation of the single phase inverter. Definitely I will discuss in details in when I will discuss about the single phase inverter in this chapter. Okay, so now the several applications of the power electronics. What are the most important applications? Okay, so you can know already. I have already discussed that application range. So you can see that power level. So it's your application. So power electronics applications. Okay. So what are the power electronics application? So you can see that power level encountered. So that power level encountered in the high frequency converter. So less than 1 watt in the battery operated portable equipments. Okay, so we can understand that how much application. So less than 1 watt. One is less than 1 watt application. So then 10 to 100 or the 1000 of watt in the power supply for that computer or the office equipment. So it is normally used for computer and the office equipment. Okay. So now the kilowatt or the megawatt in the variable speed of motor drives. Okay. So definitely. So first it was less than 1 watt. Then you are going for the 10 to 100 or the 1000 of watt in power supply. Okay. In the that is applied in the computers or the office equipment. Then kilowatt to the megawatt range in the variable speed motor drives. Okay. Then 1000 megawatt. Okay, in rectified and the inverted utility the DC transmission line. Okay, so means it's the HVDC line. Okay, so you can understand the range of the application. One is the very less power application, one and less than 1. Then 10, 100 or 1000 watts of power supply. That is second. Third one is the kilowatt to megawatt range, variable motor drive supply. That is normally used for vector control, okay, scalar control of the machine drives, okay. And another one is you can say like that HVDC, so source side power supply to the grid, okay, like that in wind turbine. So HVDC, so 1000 megawatt in the rectified inverter based application means DC transmission, HVDC. So the computer based power supply that I already discussed. So what you can see over there. So definitely AC is there in your desktop or laptop computer. In laptop computer normally what happens, directly you are giving plug-in AC, then there is some rectification is there for the battery charging. Okay, so lithium ion battery is there. So for the computer, so that will be charged over there. So AC current is there, then it will be rectified, then filter circuit is there. So filter circuit, then DC-DC converter is there. So one is for charging purpose, regulated DC output for the all the applications and the load. Okay, so that DC supply is normally known as the DC capacitor. Okay, that is maintaining the ripple, mitigating the ripple. Okay, so in it is pulsating DC, pulse DC will get. Okay, so because it's an AC, then rectified pulse DC will get. So how much value is there? 85 to 265 voltage RMS. Okay, so DC link, so it is called DC link capacitor. So it will maintaining the voltage. Okay, the balancing that voltage. Okay, how much value is there? So balancing the DC link capacitor is also another research topic. Okay, but DC converter is there. So that is responsible for regulated output voltage. Okay, so regulated output voltage that may be used if you see the SMPS of your desktop computer. But in case of laptop, you are not able to open it, but desktop you can open it. So you can see the different supply, that regulated supply is coming different terminal, maybe your hard disk, okay, your processor, lots of things are there. In processor directly it is coming, hard disk is coming, then DVD drive is there, that directly coming over there. Okay, so all the required power supply in your laptop, in your computer, it will be observed. Okay, then load is there, sometimes other loads may be there. Okay, so you can say like that, one regulated DC supply, another one is load. So regulated DC supply is coming from here. So it is load number 1, load number 2. It is load 1, it is load 2. So you can say this load is directly coming to your processor, This load is directly coming to your hard disk. Another load may be there that is coming to your DVD drive. Okay, so sometimes what happen, internal speaker is there in your CPU. So some of the percent is there for the speaker. Okay, so you can I think you are observed about the power supply. Then there's variable speed. So it was basically computer power supply system. Then you can go for that variable speed AC motor drive system. Okay, so where you can see, because previous one it was single phase AC. Okay, now it is three phase AC. Okay, three phase AC like 500, 550 or 60 hertz as per the convention. In India you can use it 50 hertz. In other country you can make it 60 hertz. Okay, so then the rectifier will be there definitely. Rectifier means it will be regulate, means it will converting that AC to DC. Then you will get the DC link voltage, that is V link. It is a DC link voltage because again the capacitor is there. So you have to maintaining the DC link voltage. You have to using what type of capacitor normally you have used, electrolytic capacitor. Okay, as per the voltage rating, it looking big shape. Okay, it looking like cylindrical in nature. Okay, electrolytic capacitor in big shape means its nature is almost big, so 1000 microfarad. Okay, but voltage is, if you see the how much voltage will be there. So three phase AC line means again that 400 volt will be there nearer to the 400 volt. Okay, so again you have to purchase one capacitor, DC link capacitor. The range of the capacitor is beyond 400, otherwise it will be burst, means it will damage. Okay, in previous case you can say that RMS is 265. So again another capacitor will be there, that will be the voltage will be up to 300 volt of DC. Okay, so you can understand that as per the application, the parameter selection, that means that element selection will be done by your side. Okay, then you are using inverter, because inverter is the DC to AC conversion. So then variable frequency and variable voltage range is there, because in inverter you are converting DC to AC. So what type of AC? In my first class I have discussed about that regulated AC will get. So in that case maybe voltage may be varied and the frequency also will vary by changing of what? How to changing that frequency? If you vary the modulating frequency of that inverter, so definitely it will change. Okay, the pulse width will also be changed. So inverter output frequency also being changed by changing of the modulating frequency. If you change the carrier frequency and as well as carrier frequency, so what happened? The pulse width, the PWM pulse width will be changed. Okay, so if the PWM width will be changed, okay, as per the changing of the frequency of the carrier signal and the modulating signal, PWM width also be changed. So if the PWM width has changed, definitely the frequency may be varied sometimes, and as well as the output voltage also be varied, because on time is less, means if all the PWM is very on time is very less of the PWM, so output voltage definitely will be less. Okay, then what happen? You can change the voltage as well as the frequency. So you are in machine drive, you can use such type of configuration. Okay, then spacecraft power supply. Okay, so in case of spacecraft power supply, you are using as a renewable as a input. Okay, so which will be the renewable? Which type of renewables normally you have used? Normally we are using the three types of renewables. One is called fuel cell. Okay, in spacecraft, okay, normally you are using fuel cell. Another one is the battery pack, and the most important it is your solar array. Okay, if the renewables are there, so definitely some integration, you are not able to directly integrate the renewables to your internal grid of that spacecraft, because it's an independent source of power, it having independent sources of power. So that's definitely there is some different grids. Okay, in single grid will be there. So solar array you have directly connected to a DC-DC converter, because output of the solar array is DC. So again it will be directly converted or it will be regulated. So directly DC-DC to your solar panel. Okay, so from the solar panel to your DC grid. Then battery pack is there, definitely some battery charger circuit as well as charging as well as discharging. Both should be done by this converter. So normally we are using bidirectional converter. So if the battery packs are there, so definitely there is some battery charging and discharging circuit. So both should be in a single one. So it is called bidirectional converter. Okay. So dissipating shunt regulator is there. Why it is important? Because heat sink, different issues. So DC-DC converter is there for payload. Payload means, you know, that is very common term of that spacecraft, that payload. Okay. So DC-DC converters are normally used for that, all those payload. Okay. Payload means it may be its inherent weight. Okay. It may be other instrument that is working on based on that current power generated by your internal grid of that spacecraft. Okay. So payload means you are paying for this load. Okay. Because how much if it is very bulky in nature, if the weight of that weight of that spacecraft is bulky, means you have to definitely you have to overcome that load against the gravity. So all the things also be the all the things should be the considered. So high density power supply you have to be incorporated. It is required, okay, for overcoming that payload. Okay, I think all of you are able to understand the basic conceptions. Okay, so the basic realizations of this subject. So elements of that power electronics. So what are the most important elements are there? So power electronics incorporate the concept of the field of which elements are there. So that is called analog circuit, because in your control circuit totally based on that analog devices. Okay, power devices, power electronics devices and analog electronics devices both are different based on their doping, based on their voltage range of applications, based on their switching frequency. Lots of differences are there in between analog electronics and power electronics. So normally most important thing is that doping and that voltage level. So voltage level is most important. If the voltage level is different, then definitely the doping will be different. Okay. So so first thing is your analog circuit, that is normally used for your control circuit. So electronic devices. Okay, what are the most important electronic devices? Means you are using switches, solid state devices are there. Then control system. So you are using different controller. It may be analog controller, it may be the digital controller, it may be real time controller. So whatever may be your controller there, whatever may be the advanced controller there, definitely it is required, because if the sophistication of the device is increasing. Okay, so sophistication of the device increasing means, if definitely the cost more costlier control circuit will be there. So you know right now FPGA based microcontroller, lots of complicated supplies are there. IP module means that is called intelligent power module. Okay, so all the cases it having some own deciding factor. So how it will work by itself. So all the things depends upon your control system. Okay, so this is another most important thing. So power system, why that power system is important right now? All the renewables, okay, all the renewables directly connected to your grids. Okay, so through the power electronics converter it is normally interfacing. Now the grids are there, as well as the grid is standalone condition, maybe maybe islanded condition, maybe grid connected condition. Means your system you have designed, that's a standalone condition, means all the individual renewables connected to your system, and you have established your own grid in your home. Okay, means now you are not connecting your home household microgrid to your utility grid. Utility grid means that provided by the government. Okay, so you are not connecting both of them. So you can say like that it's a standalone system, and your all the equipments, all the necessary power consumption, power appliances working and working on your individual microgrids that you have installed in your home. Okay, so there is no such connections with that utility grid. Utility grid means conventional grid. So if it's connected with the conventional grid, so there is some integrations between that your microgrid, personal microgrid with that utility grid. So some interaction will be there. So again, it's related to the idea from the power system. Okay. Then the magnetics, most important issue, that magnetics. So how do you design that inductors of your switch mode power converters? Okay, that is most important issue, because you can understand that switching frequency is too high. Okay, so normally ferromagnetic elements you are not able to use over there, because there is some problem of the core saturation. That's why you have to go for different ferrite. Okay, different ferrite material, different compositions of that ferrite material. Ferrite material means the ferromagnetic substance, it's you are making it dust. Okay, then you are preparing some structure, means different transformer look like. It's not directly ferromagnetic material, means definitely it's an property, because it's your magnetics is normally defined or normally designed by the ferromagnetic dust particles. Okay, then it will be some compositions with the other components. Okay, so ferromagnetic components and the other components, and you are preparing your magnetic circuit. Okay, that is most important for high frequency application. Right now the GAN devices, SiC devices we are using, that having megahertz range of operation, but if your magnetics is not supporting that amount of high frequency operation, so your converter will not properly work. So that saturation, magnetic saturation, another big issue, so it should not be saturated. Okay, so that's why you have to design your magnetics as per your application, as per the, you have to select that components, ferromagnetic components or the ferrite components. Okay, so which you are going to be used for your converter. Then electric machines, for the drives you are using electric machines. Numerical simulation. Okay, so all the thing is relatively real time application. Okay, so but you have to do first numerical application, numerical calculations, otherwise you are not able to understand that, otherwise you are not understand that your system is mathematically working or not. So if it is working in your simulation, then you can go only for that experimental purpose. If it is not satisfied your simulation computational platform, so you are not go, you will not able to go for that hardware experiment. Okay, you can go, but whatever the, because all the components are costlier. Okay, it will damage comparatively the simulation. So there is no such problem of the damage. So first you have to satisfy the computational result, if it is working well or not. If it is perfectly working, so there will be no problem. If it is not perfectly working, so you have to find out the faults. If your simulation is convincing, then you can go for that hardware realization, hardware designing of that switching converter. Okay, so all the different steps are most important for switching converter, for the designing of the switching converter. Okay. Now different converter equilibriums are there. So I have presented some of the slide over here, but details explanation will be discussed in my later slide. Okay, the modeling purpose, so how that average modeling is there, so then how it will be coming. So this circuit, so again I will be discussed. So again the magnetic circuit is there, that's why magnetic coupling is there. Okay, so everything I will be discussed. For inductor waveform, that I have already told you. So for charging purpose of the inductor, discharging purpose. So initially it is positive half, then it will be negative half. So in my second last class I discussed about the voltage appear across the inductor. Why that inductor is working in that DC condition. At that time I told you that switching frequency is too high. So due to the high switching frequency, inverter is facing, that means the inductor is normally facing the output voltage of the inductor. You can see it's in alternating in nature. Okay, so initially it is positive up, then switch on condition it is positive up, then switch off condition it will be negative up. That's why alternating in nature. So current is changing over there. Okay, ramp changing of that. So that's why it is working. Okay, I think you are able to understand. So again there is some two mode of operation, continuous mode of operation, discontinuous mode of operation. So continuous mode of operation means your inductor current, the initial inductor current, and it's your final inductor current. Okay, so it's not touching to the zero. If it is touching to the zero axis, mean x axis, so you can say like that it is discontinuous mode of operation. If it is not touching over there, so you can say like that it's in continuous mode of operation. Everything it will be coming. Okay, so then some switching realization is there, switching device realization there. So I will discuss in separate chapter. Okay, so it's a very brief about different chapters. So that is related to the converter modeling. Okay, that chapter is related to the converter modeling and the steady state application. Now switching realization. So different type of switches will be used when semiconductor devices are used, like IGBT, like MOSFET, like BJT. Okay, then different switches like SCR, thyristor, lot of switches are there. Okay, so which one we are going to be used, that is most important. Okay, so here you can see the collectors, emitters, and the gate. For the BJT, for the IGBT, it is compositions of the BJT and the MOSFET. Okay, so it's the structure. The details discussion about the structure I will discuss in my other classes. So one specific chapters will be there related to the switching devices. Okay. Then the converters in the equilibriums. Okay, so which are the most important thing you need to be studied, that it is that your power electronics converter is working in the equilibrium or not. So which are the most important thing? The principle of the steady state of the converter analysis. Okay, so steady state analysis of the converter is important because at steady state the regulation. Okay, that I am telling you, that steady state study means regulation study, that you have to observe. Then steady state equivalent circuit model. Okay, because then modeling is important. Okay, so for designing that controllers. Okay, so controller means you are designing the controller, means control is totally mathematical, mathematical subjects. Okay, so first your converter is it's an physical, means you can realize physically, so you have to convert your physical system to the mathematical domain. So who is responsible for converting that one? So modeling. So I discussed about the converter modeling in my other classes. Okay, so it's in different chapters of the switching mode power converter, power devices, modeling, controller designing. Okay, then the applications. Okay, that individual chapters I will come in my individual this lectures. Okay, so it's the introductory lectures, that's why I am giving the very brief about all those chapters. Then switching realization. So if one switches are there, if one switch is there, so what will be the mode on operation? Means switch on operation, switch on operation. If different switches are there, so what will be that operation? So different switches are there. Okay, the discontinuous conduction mode. Okay, discontinuous conduction mode means in my last slide I discussed about the continuous conduction mode, discontinuous conduction. So why it is important, that having some another effect. So continuous conduction mode is important or discontinuous. So as per your application, in case of continuous conduction mode the ripple is less, but in case of discontinuous conduction mode the inductor current is ripple is high. But those converter having non-minimum phase problem, that may be mitigated or that may be minimized by the discontinuous mode of operation. Okay, so that's why sometimes we are also using discontinuous mode of operation, but that you can say like the non-minimum phase problem also will overcome by the control structure also. Okay, so we are having some work on it. Okay, so still I have already told you that my PhD topic is totally based on the switch mode power converter. So I have a lot of work on that non-minimum phase system converters. Okay, as per their application same, as per their switching range and continuous mode of operation, discontinuous mode of operation, and control application on that, how do you overcome all those things. So if possible, so I will show you some of the studies over it, so you can realize, you can understand that practically how it will work. Okay. So converter dynamics and control, you know that slide, that one. So it's a structure of that control signal. Normally it is slowly varying, the frequency is very less, and now we are comparing with some triangular one. Okay, so it is closed loop converter system. You can see that closed loop converter system. Then averaging of that waveform, because switch on switch off things are there, so finally we will get some average signal. Okay, like that. Okay, that averaging chapter will be coming, that converter dynamics and that control. So it will coming later. Okay, so it will be coming. So small signal average equivalent circuit. So how the circuit is coming, that also been discussed in my other lectures. Okay, but it will be coming. So here you can see the switching converter is there, input power, output load is there. So feedback connections is there. I have already told the sensor circuit is there. Then compensator, comparing all those steps, PWM is there. Finally get it. Okay. So how do you realize the inter circuit through that equivalent circuit? That is your small signal averaging method. Okay. So normally all the converters, means switching converter is the non-linear. For what? Because initially there is two steps. One is cutoff region, another one is saturation region. So quasi-saturation region and the cutoff region, the converter is working. So either on, either off. So on of non-linearity normally observed over here. So due to non-linearity, so when you are going to be design the controller, so you have to convert the non-linear system to the linear system. That's why you are using small signal averaging method. Okay, for converting the non-linear system to the linear system for designing your control structure. That's the motivations for converter dynamics and the control design by using averaging method. Okay. So then what are the most important topic for converter dynamics? Means AC modeling, converter transfer function, controller gain, then AC DC equivalent circuit modeling, discontinuous conduction mode, then current put down control. So in case of different controls are there, current mode control, again current mode control, three types of controls are there. One is called peak current mode control, another is called value current mode control, another is two mode actually, peak current mode control and valley current mode control. Another control is there that is called voltage mode control. Okay, the difference between voltage mode control and current mode control definitely I will discuss. Okay, that is very important idea. Which control we are normally using. Okay, normally current mode control dynamics is much more faster than your voltage mode control. But current mode control having two loops, but voltage mode control having only a single loop. So for the single loop operation, if you are getting very fast dynamics, that is much more acceptable because current mode control is quite complicated compared to a voltage mode control. Okay, then magnetics issue that I am going to be discussed. Okay, so ferrite core is there. I think your time is almost over because your next class will be started. Okay, so I have to converge or wind up the enter the lecture. Okay, so magnetics are there. So different basic magnetic theory. Okay, so basic magnetic theories are there. Then filter inductor design, transformer design, means all the cases you are using then high frequency operation. So high frequency magnetics means ferrite core you have normally designed. Okay, that's the issue. Then finally the modern rectifier. So how it will be work. So all the things are much more same, but you are using that bridge circuits over there, then input voltage, then rectifier bridge, and it's called the peak current mode, PFC. Okay, so it is called PFC converter. Okay, low harmonic rectifier system, power factor corrected converter. Okay, PFC. Okay, so that's why it is called feed forward control. So input side current you have also be fetched as well as the output side voltage. Okay, both of the thing you have been fetched over here. So PFC converter is there for reducing the input harmonic cycle. So improving that input power factor. Okay, I think all of you know about the performance index. So what is input power factor? What is the definition of input power factor? What is displacement factor? Okay, so all the things are there. All the ripple factor. Then what is your form factor? Peak factor. Lot of things are there. I think that will be covered in your power electronics subject. Okay, means core subjects. Okay, so I think you have go through it from Rashid. Okay, Rashid book. All the things are already available. But in my case, I am not following the Rashid because this kinds of portion I think is some of the portion is there in Rashid, but details application is there in Ericsson book. Okay, so I am following that Ericsson book and other different. I normally I am following 3-4 books. Okay, for the power electronics converter. I have shared the name of the books. Okay, so you can go to the introductory slide, so you can see some of the books, reference books. So 3-4 books normally I have followed. Okay. The modern rectifiers. Okay, so I think you are able to understand. So what are the modern rectifiers? Then finally resonant converter, resonant tank converter. Okay, so importance of the resonating tank converter. Okay, so that question also being there. So ZVS, ZCS, means zero voltage switching, zero current switching. If time is there, definitely I will cover all those things. Okay, so that is our main layout of the course of the switch mode power converters. I think all of you will to understand that what is the motivation of the subject and finally what you need to cover. Okay, so I think all of you can able to understand the topic of my studies. Okay, so thank you all of you. So again we will